Hi everyone, I'm Dr. A. Season and welcome to our course, Thermodynamics. Today, we're going to discuss the different types of energy.
But first, let us discuss the definition of energy. Energy is the capacity to do work. The greater the energy of a body, the greater is its capacity to perform any work. This means that whatever work is done on an object, it gains enough energy. If 1 Newton meter of work is done, the object gains 1 Newton meter of energy. The energy may be stored by the object in a variety of ways. First is kinetic energy. It is the energy possessed by an object by virtue of its motion. Next is gravitational potential energy. It is the energy possessed by an object because of its position. Next is internal energy. It is the atomic and molecular energy of matter consisting of the kinetic energy of the atoms and molecules due to their random motion called thermal energy, and the energy atoms and molecules have as a result of their bonds and interaction with each other. The force of gravity and the force exerted by an ideal spring are called conservative forces, whereas the force of friction is a non-conservative force. If the force can be expressed in terms of only position, not of velocity or time, we call this force a conservative force. A conservative force may be associated with the scalar potential energy function, whereas a non-conservative force cannot. Now let us proceed to work and change in kinetic energy. You have learned from previous lessons that work and energy are interrelated. The total work done by the force as an object moves equals the change in its kinetic energy from Newton's second law. Change in Ke is equals to work, or it is equivalent to F multiplied by change in displacement, or simply it is Ke is equals to 1/2 mv squared. Now let us proceed to our example problem. A 0.10 kg stone is thrown from the edge of an ocean cliff with an initial speed of 20 meters per second. When it strikes the water below, it is traveling at 45 meters per second. What is the change in the kinetic energy of the stone? First, you have to analyze the problem and identify what are the given and unknown. So from this given problem, the given are the following. The initial speed is 20 meters per second and the final speed is 45 meters per second. The mass of the object is 0.10 kilograms, so you are asked to find the change in the kinetic energy of the stone. For our solution, we're going to use the formula for change in Ke is equals to 1/2 v squared, or substituting v as the change in the speed of the object, v sub f squared minus v sub I squared, or the final speed minus the initial speed. Substituting the given from the formula is equals to 1/2 multiplied by 0.10 kg multiplied by 45 square minus 20 square meters square per second square. The answer for the change in Ke is 81.25 joules. Now let us proceed to work and change in gravitational potential energy. Whenever work is done on an object that changes its elevation or vertical distance, the work done is equivalent to gravitational potential energy gained by the object. Thus, change in GPE is equals to work, or it is equals to force multiplied by the change in displacement, or mg multiplied by the change in height, mg multiplied by final height minus the initial height, or simply GPE is equals to mgh. Now let us give an example. A 400 kg roller coaster cart is 48 meters above the ground. Calculate the change in potential energy of the car. The given are the following. The mass of the roller coaster is 400 kg. The initial height is 48 meters. The final height is 3 meters. You find the change in GPE. Using the formula change in GPE is equals to mg multiplied by the change in height, we have our solution 400 kg multiplied by 9.8 meter per second square multiplied by 3 meters minus 48 meters, we have negative 176,400 joules. The negative sign denotes that the movement of the object is downward. Now let us proceed to power. When we say power, it is the rate of doing work. Now we have here the equation for power. Power is equals to work done over time, or power is equals to force multiplied by D over T. But D over T is equals to V sub S. Therefore, power is equals to F multiplied by V sub S, where F is the force applied on the object, D is displacement, T is the time taken to do the work, and V sub S is the average speed. Now let us proceed to a given problem. A car is traveling at a constant velocity of 100 km per hour on the skyway. What is the power output of the car engine? If the total air resistance and friction between road and tires is 750 newtons.
The given in our problem is the total air resistance and friction between the road and tires of the car, and that is equivalent to 750 newtons. Another is the car is traveling at a constant velocity of 100 km per hour. So we are asked to find the power of the car. So we have here the solution. Power is equals to force multiplied by the velocity of the car is equals to 750 newtons multiplied by 100 kilometers per hour. So the final answer is 21 kilowatts. Now let us proceed to the law of conservation of energy. The work energy theorem then leads to the principle of the conservation of mechanical energy, the idea that the motion of an object is governed by something that does not change, had its origin in the pendulum experiments of Galileo. According to the law of conservation of total mechanical energy, the total mechanical energy of an object must be conserved among all the different positions that the object may be. The law of conservation of energy can be expressed as change in Ke plus change in Pe is equals to 0. That the energy can be changed into different forms, but the total energy of the system is constant. So if you have questions, comments, or feedbacks, you can message me at our messenger, or you can email me at maricarh2001@yahoo.com. Thank you and keep safe.